All right, so we're continuing on with the improper integrals. So this is one of the other instances where you're going to have an improper integral. So if we had this integral from -2 to 2 of the function 2 over x, we could graph the function, which is right here. And we notice between -2 and 2, there is a discontinuity here. There is an asymptote. So what we have to do is treat a little bit differently than what we did before, but very similar. We have to split up the integral into two integrals at the discontinuity. So we have from -2 to 0, because that's where our asymptote is, of the function, plus the other one, so from 0 to 2. Okay. Alright, so first step is a little different in these cases when we're not dealing with the ones that have infinity. But now what we want to do is we want to think limit again. But instead of replacing the infinity on these ones, we're replacing the discontinuity. So we can go ahead and we can take a look at one of them at a time, because if one of them is divergent, then the whole thing's divergent. So let's go ahead and take a look at from -2 to 0, so the left side of the integral here. All right, so we're running a limit again from b, so as b approaches 0, of the integral from -2 to b, and then 2 over x. Alright, so we have that. So now if we go ahead and integrate 2 over x, we know that becomes 2 ln x. And we're going from -2 to b. For our natural log. So we go ahead and plug those in. Natural log of b minus 2 natural log of -2. Okay. Still doing limit of it. So the 2 ln -2, so we have absolute values here, so that would be a 2. So we would get a value for this part. As far as when we plug the 0 in for the b to evaluate the limit, we are in the case, so we have to think about what the natural log looks like again. So we need to know what the graphs look like. Your natural logs, your exponentials. Any of these, we need to be very comfortable with what the graphs look like. So as I approach 0 for natural log, so we're going to the left, we're approaching 0, what's happening with the function? The function is going down. Remember, there's an asymptote here. We are going to -infinity. So this is -infinity, this is a finite value, but it doesn't matter. As soon as we have that infinity or -infinity, we can say that this is divergent. Okay. So again, we have to know what our graphs look like. Or just remember the fact that you can't take natural logs of 0 or negatives. So that's why we have absolute values, but the absolute value does not help the 0. So that fails. All right. Let's take a look at another one here. So this is a similar case, but a little bit different. So we have from 0 to 1 for 1 over x cubed. So if we graphed 1 over x cubed, here's the graph. We're going from 0 to 1. We're trying to find this area under the curve. The problem is one of our boundaries is an asymptote. So what we need to do is similar to what we did in the last problem. We're taking and we're replacing the asymptote with b. So we're going from b to 1 for our function, for our integral. Okay, so now we need to integrate. If we integrate this, we would end up with negative 1 over 2x squared. Oops, not dx. So from b to 1. Okay. So now we can go ahead and evaluate. We get negative 1 over 2 times 1 squared when we plug the 1 in, so that's just negative 1/2, minus a negative, so we're adding this. So 1 over 2 times b squared, and we're running the limit as b approaches 0. So we gotta have a negative 1/2 here. We plug in 0 to this, we get 2 times 0 on the bottom, so we have 1 over 0. So this right here is undefined. So it's a little bit different in this case. We have an undefined value, so that does not exist. So if we have does not exist or undefined, this is divergent. And remember, if you do not get a finite value, it is divergent. So whether it's infinity or does not exist or undefined or something like that, it's going to be divergent. Okay? Alright. So that is it. Let me know if you guys have any questions, and we can go from there.